So here we have a problem on based on average speed and average velocity. So just the heading, it is just the heading, and it has nothing to do with any kind of distinguish. It is just the heading. Okay, an object is moving in a circular path. We have to be very careful which way the object is moving. If nothing is given, then it must be a straight line, but if it is given, we have to follow that. Circular path of radius 10 meter. If it covers quarter of the path, in my previous video I've given the same kind of problem to find distance and displacement, so same logic will be applied here. uh, in 3.14 second, I've purposely given this value because we know value of pi is 3.14. Find average speed and average velocity. So first we'll draw its diagram. It is not mandatory, but it will give us a feel of this question. There is a circle and its radius is 10 meter. It covers quarter of the path. Quarter of the path is not the proper word. Quarter of the circumference. Okay. Quarter of the circumference. Obviously, this angle is 90 degree. There is also radius 10 meter. So we need to find this, which is the circumference. This is distance is equal to quarter of the circumference. That is, if we cancel it, pi r by 2, pi is 3.14 multiplied by 10 divided by 2. I'm not doing anything with this. 3.14 multiplied by 5 meter. And then time is also given. 3.14. I purposely given it like that, but anything can be. Okay, speed equal to distance upon time. We can also write average speed is total upon total time. Nothing wrong in it. Into 5 divided by 3.14. I purposely multiply both of them. 5. Remember, meter per second. Per unit. Otherwise, there will be a. Okay. For velocity, we the straight line separation between initial and final position. And if you remember, displacement is equal to this distance, which is hypotenuse, 10 square plus 10 square, what I told you that day. 10 square, I mean in that day means in that video. We can directly write it like this. Oh, sorry, not this, but this. And meter. Okay, for this only. Okay, here we have a right angle triangle, both sides are equal. Then only we can do this. And now average velocity is displacement divided by time. Displacement is 10 root 2 divided by time is 3.14. Remember 3.14 square is 9.86, close to 10. So if we uh, divide it, it will be approximately 3 point more than 3.14, that is 3.16. I am writing it. You can check it on calculator or you can divide it, but I am sure that my cancellation is perfect, and now its velocity is 3.16 root 2 meter per second. And see, value of root 2 is 1.414. So we will take it up to first decimal place 1.4, and if you will multiply it, so 1.4, if you will multiply, it will come excuse me, approximately 4.3. I might be wrong with this decimal places. Maybe it will be around uh, some second decimal place, but I'm rounding off it off to first decimal place only. You can leave your answer as it is. So once again, see, once again, I will keep on reminding you that the concept of distance and displacement is irrespective of the way the object is moving. It is moving in a circular path, but still it can have distance as well as displacement. It can have speed as well as velocity. Okay, moving on. Next question. Okay, a sprinter, maybe for few students it is a new term, sprint race, straight line for 100 meter it is, in which athlete just runs, and there's no uh, time for a racer to um, make any strategy. Just sprinter has to run. Okay, sprinter runs with a constant speed. Oh, sorry, I always forget this. Of 10 meter per second. How long will she take to run a distance of 110 meter? So it is a direct question, nothing to do with it. So speed is given. We'll directly apply this into the formula. Speed equal to distance upon time. Speed is 10 meter per second, distance is 110 meter. While calculation, we don't put the unit. We can put, but it will lead to an unnecessary confusion. So that is why I am not putting unit here. Upon time, time is just t. So if we cross multiply it, 10t is equal to 110. So t equal to 110 by 10, that will be 11 second. How I know it will be in seconds? Because the units are meter per second, meter, so time will be in second. All right, so next question. There are two questions. Both are similar to each other, just a slight change. Not of the font, but there is a slight change, but ultimately both are same type of question. A train runs from station A to B at a speed 100 km per hour, returns at a speed 150 km per hour. Find its average speed and average velocity. Okay, So in this question, there is a point A, station A, there is station B. First, the train runs from A to B and then returns back. So we will do the second part first. So here, displacement is 0, or we can say net displacement is 0. So average velocity will be net displacement divided by time. Uh, they haven't given us time, but we know when displacement is 0, then everything will be 0. Average velocity is 0 in this case. What about speed, average speed? So just remove that thing which is coming in your mind, that add both of them divided by 2. No, average means overall speed. So there is a well-mannered pattern to solve this type of question. Just follow the instruction. First of all, we'll assume that the distance between A and B is x. Then for A to B, speed equal to distance upon time. Speed is 100 kilometer per hour. No need to change because we are going to give the final answer in terms of kilometer per hour. So no need to change the units into meter per second unless it is asked. Distance is x and time, let us suppose t1. I am putting subscript 1 because we will have another time when it will return back. So t1 it is. Now a cross multiplication, I am taking t1 here, it will be 100 t1, that will be equal to x. I am showing you each and every step, but you can skip some of the steps. t1 equal to x by 100. So in the same way, for B to A, it will be 150 equal to x by t2, and obviously we can write it directly, we can skip some of the steps. Here it is. Next we will find total distance, which we do not know. You know, we have assumed distance as x, so it will be x plus x, that is 2x. And total time will be t1 plus t2, that is x by 100 plus x by 150. 300 is the LCM, 100 multiplied by 3, so it will be 3x plus 150 multiplied by 2, that is 2x, so it is 5x by 300, so it is x by 60. Excuse me. All right, still job is not done. Now average speed is equal to total distance by total time. Total distance is 2x and total time is x by 60. So it will be 2x multiplied by 60 by x. Answer is 120 kilometer per hour. It's a lengthy question. There is a shortcut for it also. But before that, let's try this one. But the shortcut will work for only this type of question where the same distance is traveled and only two speeds are given. So uh, let's try that method for this question. So again, uh, this is the path A to B to C. A to B, let us suppose distance is x. So here also half of the distance. So let us suppose entire distance is 2x. That will be much easier to understand. So half of the distance, half of 2x is x, and rest of half again x. So this question is quite similar to this question. If instead of, like if A to B, instead of returning back, if there is another station C which has same distance, it is not looking nice. Let us suppose now it is approximately both are same. So the same question um, uh, can be framed uh, as this question I have framed for you. And this question is similar to this question. So see the similarity between both the questions, and then I'm going to derive a formula, and using that formula you can directly apply that formula and you can get the answer in few seconds. But for such type of case only. Now see, if for A to B I take speed as v1. Oh, uh, till now you are using the symbol S for speed, but now things have changed. Now you have to use V for speed as well as for velocity, and S will be used for distance or displacement. So this is a new thing. I haven't spoke about it in my previous videos because by the time uh, the term speed, I was using the term speed and distance. I was writing entire in word form. But if we want to replace these words with symbols, then remember, speed and velocity, symbol for both of them is V, and distance and displacement, symbol for both of them is S. Sometimes people say that for velocity we write an arrow over it, and for displacement we write an arrow over it. Yes, of course, but then put a mod on both sides also. Excuse me. So speed is v1, and for B to C speed is v2. Distance is, here it is given x, here also x. So time will be actually, if we cross multiply time here like that, oh, what is this happening? if we cross multiply time here, then we have to take this speed there. So time equal to distance upon speed. This one also, this little one, I can take this one. Oh, it's not coming. Anyway, time equal to distance upon speed. Distance is x. Speed is v1. Here also, this is time 1. So time 2, distance upon speed. So total time will be t1 plus t2, that is x by v1 plus x by v2. Taking LCM, v1 v2 will go here, x v2 x v1, we can take x common, v1 plus v2 divided by v1 multiply v2. So average speed will be total distance. Total distance is 2x upon total time. Oh, sorry, this is x. X will get cancelled and the end result will be 2v1 v2 upon v1 plus v2. Well, well, well. If we could distinguish, we could identify this problem and we could relate it with this formula, then the entire working will be reduced as average speed. I'm again doing this question is equal to 2v1 v2 upon v1 plus v2, and 2v1 was 100, v2 was 150 upon v1 plus v2, and that will be 2 into 100 plus 150 divided by 250 and 25 forza. So simple. So also here average speed. Now I will use symbol for average speed also. VAVG is equal to twice 40 multiplied by 60, 40 plus 60, that is 2 into 40 multiplied by 60 divided by 100. So 48 kilometer per, oh sorry, it was in meter per second. But what if there is a question in which the journey has been divided into 3 equal parts? So let us suppose, I'm not stating the question here, I'm just drawing it. Now let us suppose object moved here, then came back, and then again go. Or you can imagine it like this also, that object has moved from A to B to C to D, or entire journey, the 1/3 of the journey, so entire journey we will assume as 3x, so 1/3 of the journey means x, it has traveled with velocity v1, speed v1. uh, in fact, we can use the term velocity also here, so nothing serious about it. This with v2 and final with v3. Then time equal to distance upon speed. Here also distance upon speed, and here also distance upon speed. So total time t is equal to t1 plus t2 plus t3. So x upon v1 plus x upon v2 plus x upon v3. This time I'm taking x common. You can do it in previous also. Oh, sorry. uh, LCM will be v1 v2 v3. It already has v1, it is deficient of this v2 v3, so we have to multiply it by v2 v3. Here v1 v2, and here v1 v3, and here v1 v2. Well, so average speed is equal to total distance, that is 3x, upon total time x. I can change the order, v1 v2 plus v2 v3 plus v3 v1 divided by v1 v2 v3. X will get cancelled, so finally it will be 3 v1 v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. Similarly, we can do it. Actually, this type of question will never come, but if it would, if the journey is divided into 4 equal parts, 1 2 3 4, and the same type of situation is there, it is equal, all parts are equal, and v1 v2 v3 v4 were the speeds, then we can say that now I'm not calculating it. You can give a try, and you will end up with this v1 v2 v3 v4 upon v1 v2 v3 plus v1 v3 v4 plus v1 v uh, v1 v2 v3 v1 v3 v4 v1 v2 v3 v4. What else can be done? One factor is missing. I have to check it. 1 upon v1, 1 upon v2, 1 upon v3, 1 upon v4. So it will get 2 3 4. Is it there? Yes. It will get 1 3 4. Yes, it is there. It will get 1 2 4. It was missing 1 2 4. So here it is. But such type of problem will never be asked, but prepare for the worst. Here it is. So in next video we'll see some more type of problems, and especially the distinction between uniform and non-uniform motion.